Okay, so here we're going to be asked how to write a comprehensive overview of a copper chloride electrolytic cell and its reaction. Here on the left hand side we've got a picture of a cell, and on the top we have the redox potentials that we need to know. Notice that there is a power source. It's providing electrons to the right hand electrode here, and it's taking electrons away from the left hand electrode. We have a green solution of copper chloride. It's aqueous, it's dissolved in water, so this is just contained in a vessel that holds liquid. On our left hand electrode there is gas evolving. It's a pale green gas, and it's we can see it coming off here. And on the right hand side we can see a deposit, a brown deposit here. This has an increase in mass on this electrode because something's been deposited on it. Now when we write a comprehensive overview, we're going to put the following in our report. We're going to use reduction potentials here to identify what's been reduced, what's been oxidized. We're going to link these observations here to reduction reactions. We're going to justify which species are oxidized or reduced using gain of electrons or loss of electrons. We're also going to justify using change in oxidation numbers. If we're doing achievement set of 91393 for NCEA level 3, we only need to do one of these, but we should do both of them so that we cover all eventualities. Okay, we need to write a fully balanced half equation, a full balanced equation, full oxidation reduction equations. We need to calculate the cell potential, so how much, what voltage is needed to make this reaction happen, because this is electrolysis. It's going to need electricity and an electrical source, and we're going to explain, we're going to link all of these things together. Now, because this is the ionic solution is made up of copper chloride, then it's going to contain copper ions and chloride ions. Now, we know that because I've written copper chloride here, we have to be able to identify that this is an ionic solid. An ionic solid is made of ions. To identify the ions that are in the solution, we can just go to the redox couples. And the only ions in the redox couples, there's copper 2+ ions and there's chloride ions, and they're going to be the ions in the solution, and they're going to be what we start with. Okay, so in this case we talked about how this solution here contains copper and chloride ions, and remember we look at the redox couples to identify what the ions are. Because this is an electrolytic cell, okay, so energy is provided to make the reaction happen. In this case, it's the most negative one that is going to go forwards in the way that it's written, and the most positive one that goes backwards. So we write that down. The most negative one is going to be reduction. We write the reduction half equation here. Now notice we've put that the copper is a solid. We know it's a solid because the mass of the cathode has increased. And remember, cathode is reduction, 2 consonants, and that is, I remember that at the cathode it's reduction because the start of the words are both consonants, and I remember anode is oxidation because the start of the words are both vowels. So here we have copper solid, right? It's created, I know it's a solid because it's stuck to the electrode, and if we look here we can actually see that there's some brown solid stuck to it. Well, that must be this copper that's created, and therefore it must be a solid. I know that the ions are aqueous because they're in a solution. It says they're aqueous. So I've written this correctly. Remember, I had to add 2 electrons to balance this equation, and we can see here, we can explain now we have this equation that it is reduction, and we can do that using the loss or gain of electrons. Remembering, Leo, the line goes Gur, loss of electrons is oxidation, but gain of electrons, Gur, gain of electrons is reduction. So this is gaining electrons. We're going to link this gain in electrons to the observations that we see. So in this case I've said that the copper ions are attracted to the negative electrode. Right, that makes sense. They're going to be attracted to the oppositely charged electrode. Each copper ion gains 2 electrons to be produced to 1 copper solid, which is observed as a brown deposit on the cathode. Okay, now this wee bit at the start where I've said that the copper ions are attracted to negative electrode, put that in, it just makes your report a wee bit stronger. So I'm also going to explain this this reduction using oxidation numbers. Okay, it's kind of my backup. So oxidation number for a monatomic ion here, copper 2 plus, is +2, and the oxidation number for an atom with no charge, sorry, an element with has no charge is 0. So the copper 2 plus is reduced to because its oxidation number of copper changes from +2 in copper 2 plus to 0 in copper. Now I could link the observations from my from the start, where I linked the observations to the gain and loss of electrons. I could link that to their second explanation. It doesn't matter. But I need to rinse and repeat. I need to do the same thing for the oxidation half equation. So, hey, if this redox couple went forwards, the other one must go backwards. And it makes sense because we have to start with Cl- ions. So here, the trouble that we have is with halogens sometimes, and it happens at times, that people forget that there is a 2 down the bottom here. So make sure that you put a big 2 coefficient in front of these ions here to make sure it's balanced. If you don't, you're going to write down that there's only 1 electrons and everything's just going to go pear-shaped. So make sure that you balance the atoms that aren't oxygen or hydrogen first, and then balance the electrons at the end. Okay, so this is a balanced half equation. We are now going to explain it, oxidation in this case, because the first one was reduction, based on loss or gain of electrons. And remember, Leo, the line goes Gur. Leo is loss of electrons. That's the line. So this is losing electrons because it had electrons and then it lost them on the right-hand side. So we are going to say that the chlorine ions are attracted to the positive electron. I'm just going to put that one in again because that's what happens. So 2 Cl- ions lose a combined total of 2 electrons. So I'm actually being specific here about how many are lost from each, to be oxidized to 1 chlorine molecule. Now, green chlorine gas will evolve from the positive electrode. Okay, now I could just call this actually, because this is oxidation, let's just call it the anode. So green gas will be evolved from the anode. Let's just put that in brackets here. And we can also remember, say that this is oxidation using oxidation numbers. So here we have that the chloride ion is reduced as the oxidation number is -1 in chloride, and it decreases to 0 in chlorine. That's why it is oxidation. Okay, let's have a look at the next slide. We're going to go over how to write our fully balanced equation and how to write our calculate E cell value. Okay, so let's put our 2 half equations in here. So we're just copying that from what we've already done. Because they both have 2 electrons, one is gaining them and the other one is losing them, they will exchange 2 electrons equally, and we don't have to multiply an equation by a number to cancel out the electrons. So we cancel out 2 electrons from each, and then we write the fully balanced equation. Here it is. So we need this fully balanced equation if we want to get excellence. We need the balanced half equations for merit. We now have to calculate the E cell. This is a merit skill here. We take the reduction values, which is the first one, which was the copper, which is +74, and we minus the oxidation. Now, because this is an electrolytic cell, or it's electrolysis, it's always going to be negative. Doesn't matter what way round you have everything. It's always reduction minus oxidation. We always get a negative value. And here we get negative 0.60 volts. Now this is important because it's negative. It means this is not spontaneous. And of course this is not spontaneous. It wouldn't react if we just left it by itself. The only way it can react is we need to supply electrical energy. The electrical energy rip the electrons away from the chlorine and give it to, not the chlorine, the chloride ions, and give it to the copper ions. And that's how the copper ions gets the electrons in the first place. It's not strong enough to grab the electrons itself. It has to be supplied the electrons by this energy source. Notice this a negative electrode here, this cathode in this case is giving the electrons to the copper. So the E cell for this reaction is negative, the reaction is not spontaneous, and electrical energy is required to make the reaction happen. Now, you need to make sure, if you want to pass the standard, that you say that the E cell for this reaction is negative, okay? And if you want to get an excellence here, you need to say that the reaction is not spontaneous and electrical energy is required to make the reaction happen. And this is what you need to, the information you need to supply when you write a report on the electrolytic cell of Achievement Standard 91393. Hopefully this has been helpful. Good luck with your assessment.